Welcome back to Getting Started with Grasshopper. Today we're going to cover the Grasshopper interface. We're going to learn how to find and add components, how to understand their inputs, how to connect components, and how the live preview works. Let's open Rhino to get started. Let's type Grasshopper into the command bar and hit enter to start up Grasshopper. Whenever we use Grasshopper, we want to be able to see the Rhino viewport to see the preview of what we're creating as we go. So let's move the Grasshopper window to the side of the screen, or to a second screen. This way we have a clear view of our script workspace as well as of the resulting preview geometry. If we need to have a better view of the viewport, we can quickly minimize the Grasshopper window by double-clicking on the top bar. Another double-click and the window is restored. The main workspace for our scripts is the Grasshopper canvas. We can move and navigate the canvas just like the top view of the Rhino viewport. We can pan by right-clicking and dragging. And we can zoom in and out by scrolling the middle mouse button. Above the canvas, we can find the component tabs. These contain all the components we're going to use to create our scripts, and they're bundled in different sections to make finding them easier. The first three tabs are specific to Grasshopper and contain components that allow us to interact with Rhino objects, create and manage variables, and manage multiple objects with lists and data trees. The following tabs contain a more familiar geometry-specific components. By and large, these components have the same name as the Rhino commands, so as a Rhino user, you'll already be familiar with most of the command names and what they do. Let's take a closer look at one of these tabs. Within each tab, there are additional subsections which group the components further. If we click on the black bar of each group, the drop-down shows even more components. These are usually more specific and lesser known. Pause the video and take some time to go through each of the component tabs to get a feeling for which commands are available in Grasshopper. Now, if we want to add components to our script, there's two ways to do it. Let's drop a point component on the canvas. We can find components by going through the component tabs and subsections, geometry in our case. Then we hover over the components to see their name and what they do, and then click to select the component we want, and simply click on the canvas where we want to place it. This will add a component for us. Another quicker way of adding components is to double-click on the empty canvas and type the name of the component we're looking for. Let's add another point component. With double-click, type point, and all the components that contain a search term will appear above the search bar. The closest match will be shown at the bottom, closest to your mouse pointer. If you're not sure which one to pick, again, hover over the results to get a short description of what the component does. Then just click on your selection and it will be added to the canvas. Up here in the menu, under Display and Draw Icons, we can toggle the graphical display of the components between the same icon we see in the component tabs and an abbreviation of the component name. We will be using the text display for this course as it is more straightforward. We can copy and paste any components on a canvas with Ctrl-C and Ctrl-V. We can also copy components by dragging them and hitting Alt once. Instead of moving, a copy of the component will be created. To delete components, simply select them and hit Delete on your keyboard. Let's keep 3 of the point components on our canvas. Now, as you can see, when you just drop the components into the Grasshopper canvas, they're orange, because we didn't provide an input. By hovering over the bubble in the top right corner of the component, we can see what's wrong. Parameter point failed to collect data. In other words, there is no input. All the components with the black hexagon icon are data container components. These components don't create or modify geometry, they just store it for us. There are data containers for all geometry types, as well as numbers and text. To fill them with data, we can feed in geometry we created with other components, or we reference geometry directly from the Rhino document. Referencing geometry means that we'll create a link between actual geometry in our Rhino file and Grasshopper. If we move the geometry in Rhino, Grasshopper will pick up on it and update the script accordingly. Let's create 4 points in the Rhino top view and use them as our referenced points. To reference geometry in Grasshopper, we have to right-click on a component that we want to link to an actual geometry. In this drop-down menu, we can choose between set one point or set multiple points. Let's select set one point. The Grasshopper window will minimize. That's normal. It's to clear the viewport so we can make our selection more easily. Let's select our first point. Done. The link is now created. You can also select the geometry in Rhino first and then right-click on a component and click Set One Point. The result is the same. We can also reference several points with the same component. If we select these 2 points and go to Set Multiple Points, our point component will contain 2 referenced points. By hovering over the output, we can check how many points each component contains. Now let's create a polyline that connects these 4 points. We could go to the component tabs and look for the component, but it's easier to simply double-click and type polyline. Let's hover over the first result to check if it does what we want, and then drop it on the canvas by clicking on it. Components in Grasshopper can have multiple inputs and outputs. We can find what the inputs are by hovering over them with the mouse pointer. Up here, the component asks for vertices or vertex points that make up the polyline. And this one asks us whether we want to create a closed curve or not. As you can see, there is already a default value here, which is false. It's just like running commands in Rhino. There are several additional options in a command line, and usually these options have a default value. It's the same in Grasshopper, as we can see from this closed parameter. It has a default value, and we only have to provide an input if we want to change it. The letters on the input give us a hint about the required input. V is for vertices and C is for closed. But it's always good to check what the input is by hovering over it. Let's connect our components. We're going to feed these points into the vertices input of the polyline. We simply move our mouse to the output of the first point until this little arrow appears, and then we click and drag to create a wire. It will snap to any available input, so let's connect it to the vertices input. Then we just let go to complete the connection. To remove a connection, we press Ctrl while doing the exact same thing we would if we wanted to connect to components. We click and drag the wire from output to input of the components we want to disconnect. A small red arrow and a minus sign will show up. The polyline component is still orange. Let's see what it says. It says insufficient points for a polyline. So let's feed another point into the same input to make it 2. If we connect the second point in the same way, you'll notice that the previous wire disappears. That is the default behavior of the wires. Any new connection will replace the previous one. If we want to add the input to the existing one, we click and drag, and additionally press Shift before we let go of the wire. You will see a little plus icon appear. This way, both points are added to the input. Let's do the same thing for the last one. It's important to note that whenever we're adding multiple inputs, the order in which we plug the points into the polyline input will determine the order the points will be connected by the polyline. And since we created this live link between the points and Grasshopper by referencing the geometry, if we move a point in Rhino, the polyline will automatically be updated. As we referenced the points and created the polyline, a preview showed up in the Rhino viewport. You probably also noticed that we can select this curve. The reason is that everything we create in Grasshopper remains a preview in the viewport until we export it into the Rhino document. This is called baking in Grasshopper. We can bake any geometry we created in Grasshopper by selecting the component that contains it, right-clicking, and selecting Bake. This pop-up window allows us to specify which layer we want to bake this object to, and here on the bottom, whether we want to group the objects in case of multiple objects. Click OK to confirm. Now the curve is converted into a native Rhino object, and we can select and manipulate it in any way we want. It's important to note, though, that this baked geometry has no connection to the Grasshopper script anymore. If we move it to the side, we can see that the Grasshopper preview is still in the same place, unchanged. by default, all Grasshopper preview geometry in the Rhino viewport is displayed in red. If we select one or more components, their contents will be highlighted in green. It's a quick way to see which component generated which geometry. You can change the default preview colors and transparency in the document preview settings, this orange white circle here. We can change the color, but also the transparency of the preview. The transparency is controlled with the bottom slider. I find it most helpful to remove the transparency entirely to get the equivalent of a shaded mode in Rhino. If we change the preview colors here, the settings will only be saved for the current Grasshopper definition. Creating a new file will reset to the default red and green previews. If we want to change the default preview colors for all new files, we can go to File, Preferences, and navigate to the Viewport section. We can change the default color and transparency by right-clicking on the spheres. Once our scripts get more advanced, we need to turn off the preview of certain geometries on our canvas to better see what's going on. We can disable the preview of components by selecting them and pressing Ctrl-Q. The components with deactivated preview are shown in a darker shade of gray. If we press Ctrl-Q again, the preview will be switched back on. So if we want to hide the preview of the referenced points, we select them and hit Ctrl-Q. We can also turn the preview of individual components on and off by right-clicking on a component and toggling Preview. We change how the preview is displayed with these buttons up here. The first one will disable the preview of the entire script. The second will just show the wireframes of the preview geometry, just like the wireframe view in the Rhino viewport. And the red one, which is the default, will give us a normal preview, including shading for surfaces and polysurfaces. When we activate the Isolate Preview command, this half-green, half-white cylinder, the preview in the viewport disappears, and only the preview of the components we select will become visible. This will be helpful in more elaborate scripts to understand which component contains which geometry. Don't forget to click the same button again to return to the default preview mode. Let's say we want to interpolate the points with a smooth curve instead of a polyline. Let's double-click on a canvas and type Interpolate to see if there is a component we can use. We hover over the first result to see if it does what we want, and confirm with a click. This component has different inputs. Let's see what they are. The first one is the same as the polyline. It's the input points or vertices. The second one defines the curve degree, the default being 3. Input P defines whether the curve is periodic or not. A periodic curve is closed. This is comparable to the closed input of the polyline component, and it's also defined with a true or false value. We can see that the default is set to false. In the last input, we can define the knot style of the curve. We can leave the default. If we now want to move all the point inputs to this interpolate curve component, we can reconnect all the points individually, but there's a better way. If we press Ctrl and Shift and click and drag, we can grab the bundled wires from the polyline input and move them to the interpolate curve vertices input. With this shortcut, we can move all the wires at once. Let's move them back and forth between the components a few times to get the hang of it. Once we have a certain number of components on a canvas, it's a good idea to take some time to align and organize the components. When we select more than one component, these small black alignment boxes appear. We can use them to align the components along one edge and space them out equally. We can create space to add more components in between existing components by holding down the Alt key and clicking and dragging. This will shift everything to the right or left. To create space vertically, hold down the Alt key, start dragging, and then hit the Alt key once again. It's best practice to group components and label them. This way it will be easier for yourself and others to understand the script. To group objects, we select the components we want to group and hit Ctrl-G. We can now move all the components in the group by moving the group. By right-clicking the group, we can add a name in the top field. We can also change the color of the group by right-clicking, going to Color and adjusting it there. We can change the default color of the group here. That's it for today. Now that we know our way around the interface, we can take a closer look at the components. Tomorrow we'll learn about 3 key components that we'll use in almost every script. I'll see you there.